So hi everyone, I'm Zach Spalding. I'm the systems manager at Southeastern. We're going to talk about network design for small organizations because some of the concepts I'm going to be talking about were things you would normally do in a big enterprise, and now it's down to the equipment that you can get relatively cheap and provide a good security. So prior to being at Southeastern, I was at Marist College in the network team. I was a Cisco certified network professional for a couple of years. So I've done a few network designs and security designs in my time. So if you don't know much about how the internet or networking works, there are 7 layers to everything that gets transmitted on the internet. Every websites, this Zoom presentation, everything follows these rules. Where you start at the very top at the application, and then it travels down the network is where we talk about IP addresses. Data link is where you get MAC addresses, and physical is the actual cable. So every single packet, and this all happens in hundredths of a millisecond for all this to happen. So today's focus, we're going to be talking about the network, the data link, and physical on how for your network design and security. There are a few security things that do happen above that. Mainly encryption happens at the presentation level, where all your data, if you're doing any type of SSL certificates or anything like that, it'll happen at that level. So the physical is this. It is your actual hardware, to your actual cabling. So all of that is what makes up the physical. So if cables go bad, so sometimes you get some random packets, they get corrupted. That's a physical issue. But in terms of security, this one's actually kind of easy to secure. Lock the room. Anything that people don't need access to, you should be locked up. Mainly you don't want them stealing equipment, but also they can do bad things to your equipment. There's ways to tamper with the cabling. There's a way to tamper with your devices. You can get rogue devices that do a lot of bad things. So just to show off a couple here. So this is right on the internet. You can go buy these things, and people plug them into USB port. They plug them into network switches. And what they're designed for is to monitor your site's traffic. They look at the packets, they look at your keyboard strokes, and then they send it off site. And it's very, very popular attack. So that's what, right here, it has an access point, and somebody put a little device to intercept all the traffic from the access point, so they can mirror everything. So it's not, you should never discount securing your physical equipment or cabling and access points the best you can. Moving on. So data link. So that's the next layer up, and that's probably something people aren't familiar with. Most people are familiar with physical devices and they're familiar with IP addressing, but there's a middle area called data link. And with data link, that is more of like the technology of what you're using for connecting. So Ethernet is what's used for most places on site. Prior to doing, I actually have done work at the token ring network before. So that was, most people have never heard of token ring, but that is another one that used to be used a while back. Cable modems, the DOCSIS connection. Frame relay, and then Wi-Fi is not really Ethernet. It's 802.11 is the RFC standard for it, but that is its own data link. It's all this. That's where making the packets up. So this is the packets that we have. That way. So when it comes to making a packet, there's these addresses, or the actual hardware addresses of your network card and where you're going to. So when your packet is coming down that stack of layers, when it hits the IP address, it's looking for, I want to go to google.com. It has an IP address, and I go, okay, well, the IP address is not on my network, so then your destination would be your gateway. And then so it would do a request to find out what's the gateway address, and that becomes your destination. Again, that all happens in milliseconds. And then this is also what some of these devices I show are looking for. They're looking for these packets because people can decode them. They can look at the raw data and find out what your passwords are if they're not being encrypted. If the web data you're looking at is not being encrypted, it's all right there, easy to see if you're doing some type of data link sniffing. So that's why we look at trying to secure the physical, and we also try to secure the data link side of things. We don't want random devices plugging into it. So network sniffers, there's some very popular ones that are free out there, and network sniffers are not bad. They're used for network diagnostic tools, but they can be used depending how they get used. They can be used for bad things. Kismet's a wireless one, and Wireshark is mainly meant for wire networks, but you can use it to work on wireless as well if you're on the wireless network. So some ways to kind of help with your data link security is this technology called VLANs and wireless VLANs. Now that's something that used to be really on the high end type of stuff, but now you can get a network switch for $85 that does VLANs. With the Wi-Fi traffic, if you're just creating SSIDs of staff and then doing another one of patron, you're not really probably isolating people unless you have IP isolation turned on, which you might not. Some of the higher end routers will give you guest networks, and those should work for the most part for doing guest traffic. But when it comes to Wi-Fi, you got to think about it's plugging into a port on your switch. What else is on that switch? If you're having the rest of the staff plug in on that switch and this access point plug in your switch, well, you just expose your whole data link side to the wireless, and then that's giving access to people who are on the Wi-Fi can now access that layer. If you're doing a VLAN, we'll talk a little bit more about that in a minute, but you can use one switch, but you're kind of separating your data link out. And then just more on the Wi-Fi side of things, for staff access, you can disable SSID broadcast. That's when you go and you select networks and comes up. If you disable that broadcast so it doesn't show up like that, if it's a staff network, you should be controlling all of those devices, so you shouldn't have to worry about someone having to look for it. And it kind of helps. It's not the best, but it kind of helps. If someone's just driving by and looking for stuff, if it's not broadcasting, it can help. So security for the hardwire ports, that's more of back to just the physical side of things, securing those, your equipment, maybe also securing where you have actual wired ports in your building. So you don't have, again, random people plugging in to your staff switches or your staff design. So you have, guests, maybe, again, you'd put them on a guest VLAN or a guest switch, but it would be the same problem of just having a Wi-Fi plug-in. There's also, so as I just said, so SSIDs do not separate the networks. You got to take a one step farther and do that isolation or do that guest networking. So VLAN. So right here we're looking. This is actually a switch at Southeastern. So this can actually be split up into 8 different switches. That's how VLANs work. You take one device and you can make it into 8. In this case, 8 different devices. So we have a staff. The first one's a staff, and then we have a tenant, and then we have staff Wi-Fi, and then we have guest Wi-Fi. So if you're on those things, you can't talk between those different devices. There's rules because of the VLANs. They said before it used to be expensive. Now it's pretty cheap. So now that brings us up to another layer. So once you go in data link, we're going up to with a network layer. And this is where IP addressing happens. And this is probably where most people are familiar. Everybody knows about IP blocks and IP authentication and things like that. So when you do a VLAN or a switch, you need like an IP range for that device. So what we've all done in different ways, you got multiple switches on a VLAN or multiple switches on an IP subnet. But in this case, so we do a subnet for each VLAN. And then that way the reason we do the VLANs is so if somebody knows what the IP address is to, say, the staff VLAN and they're on the guest VLAN, they can't hard code their IP address in and jump around. They're restricted to where they're supposed to be. It also gives you the ability to do rules. So in this case, this is just a diagram of VLANs and a switch and a router. It's a very small network, very comparable to what probably most of us are working with. So right here, so you have like VLAN 100, you have, you know, this subnet, you move it up, you can just pick a random number in 110 and 120. So you could do staff, guest, devices. Some people like to take their voice over IP systems and separate them out. Sometimes they want to take all their printers and separate them out. Those are devices that, again, as tech people, we don't really have a lot of control over what happens on the hardware side of things or the software side of things. They're just devices that kind of get thrown out by manufacturers, and sometimes they update them and sometimes they don't. So once in a while, that stuff happens, and so they could be a security issue. So some places that have lots of printers or lots of IP cameras, they might separate them out. They also don't want maybe guests accessing that, especially on the IP camera side of things. Some IP cameras, if you know the default passwords, you can go in and access them. But as we're looking at this, we have our subnets, the plugging into a switch, which has been separated out to different VLANs. And then in this scenario, the router is the gateway for all of them. So this link between the router and the switch is what we call a gateway, or sorry, a trunk link. So it's trunking. So all the VLAN traffic leaves the switch as one, comes to the router, and then the router decides if it's going to the internet or do I need to route it to the other VLAN. So again, if somebody on the VLAN 100 wants to print, their traffic is going to come right through here. The switch is going to see, okay, well, you're on VLAN 100. You want to talk to a device that's on a different subnet. It kicks it to the router. The router goes, oh, you want the printer. That's on VLAN 120. So you need to come back to the switch. And then the switch goes, oh, okay, where the printer is over here. And a less secure setup, everything would be all on one switch with the same subnet. And then the computer would just talk directly to the printer. It's easier, but it does open up some security issues because you have maybe something hacks the printer. Now the printer can now access the computer, or the printer can now run a web server, a small web server, an FTP server, and start transmitting huge amounts of data. So that's why these designs happen the way they are. So this is the VLAN practice. So this is what we are using right now at Southeastern. So
hey, Zach,
how does security work in a network?
Zach?
Yes.
Do you see there's a question in the chat?
Okay.
Sorry, is VLAN the same as VPN?
No. VPN, and I'll probably cover VPNs a little bit at the end here, but they are very different technologies. VLANs are meant just for on-site and segmenting your network. VPNs are meant for you to have remote access off-site for your network. And obviously in the last couple of weeks, they have become pretty critical for mission operations right now. So we will talk about that a little bit. So back to securing your network. So if you're shopping for Ethernet equipment, you'll usually see, oh, there's hubs and switches, and the hub will usually be cheaper than the switch, but not by much. We're only talking a few bucks. And so people, oh, I'll just buy it. You know, I'll save myself $5. The difference is how they work. When you talk about an Ethernet hub, all the traffic, it comes in on, say, one port, and then the hub will broadcast that traffic to all the ports on the switch. And that's a very old design from the end of the 70s, early 80s. That's just how everything worked. Everything came in and just got broadcasted out. And when it broadcasted out, everybody on that hub sees all of your traffic. So a switch design is the traffic comes in on one port, and then the switch is looking at your data packet to find out if you're trying to find another device on the switch, or do you need to find your router / gateway. So it's a little bit more cleaner, a little more secure by having a switch. You just prevent some issues from happening right off the bat. And most places probably have switches, and they just don't know it at this point. Hubs, for that reason, have kind of been phased out, but I do come across them once in a while. As I was trying to mention before, so when you have Wi-Fi and access point, you're essentially exposing your wired network to the air, depending on your setup. So keep that in mind. If you're just having, especially if you have a hub and a access point, you're really just broadcasting all your traffic all over the planet at that point. Anyway, we were kind of talking about this a little bit before about you have a subnet for each VLAN. Now you can run multiple subnets on a VLAN if you wish, but most people at that point are just doing a VLAN per subnet. Especially for a small organization, you really shouldn't probably be going. I'm assuming you won't be going past 5 or 6 VLANs at the most. Like right now, I think I'm only doing 4. Prior to that, like this has all become cheaper. Prior to this, I used to have a tower computer. It was probably about this tall, and it had 5 or 6 network cards in it, and then I had switches for each of that. So at the time I was running the staff, I was running a server switch, I was running the Wi-Fi, and we have a tenant, so I was running that. So that's how I was separating everything out. It creates a little bit more of a management issue because you got all this hardware that you got to kind of keep track of, which ain't bad once it's running, but it's a little bit more to work with and troubleshoot. So that's so we kind of talked about that. So network design. So when it comes to building all this, in the case of a small organization, you're getting your firewall, and you probably a firewall and switch, but the firewall needs to be able to support VLANs. Not every firewall does that. It's something you got to look into. And firewalls are where you're going to spend a little bit more money, like $500, $600. So really to get a whole secure thing, you're probably looking at $700 investment. But they give you that security if it's all done, set up in a good way. So I'm going to actually do a demonstration here of this. So right here is our firewall view. So WAN, that's our internet link. And then we have the office, we have our tenant, we have Wi-Fi, we have a server network, and then we have a voice network. And 100, 200, 300, 400, 500. So that's how that all, so this is the firewall, and it knows to look for that tagging. The switch tags everything because it supports VLAN. So on each switch port, I say like port 1 is going to be VLAN 100. So all traffic gets tagged as 100. Child finds on port 2, they get tagged as 200. So when they hit the firewall goes, oh, okay, I know what that is. And it looks at the IP addressing, and it goes from there. And it knows how to route it at that point. And when it's here, we actually have rules. So on the WAN, this is the internet side of things. So we're blocking stuff coming in. But let's say on the child find side of things, I am blocking right here. I'm blocking them to talking to the office network, and then on the office network, I am blocking the office from talking to child find. And that's kind of a really quick example of how we secure that inter-building design. And that's why I'm here. So before I was talking about access points and isolation. So this, again, here's our access point. It's not a mainstream firmware. It's an open source firmware, but it gives us a lot of advanced features. And right here, it'll say IP isolation. If you're doing stuff that's more like a Netgear Nighthawk, which most organizations I would recommend to. They cost a little bit more, but they're more on the high end of a commercial private cellular access point. And when you talk about a lot of devices, they're good. And usually those will come with they might have isolation already built in, or they'll have a guest network feature built in. Sync of IP addressing when you're doing your design. So like a lot of this stuff comes in, it comes 192.168.1. If you're doing a more commercial setup for an organization, I would do something different. Like I'm doing 192, 168, 100, and then I go like 101 and 102 and 103. The reason for that is you don't get mixed up with people who bring in home devices that might have that 192, 168. You know, if they come in and they have that address and they can't connect, well, then you know why their computer's not working right. It's not doing DHCP right, or they got something hard coded or something along those lines. It also helps for VPN access. If you have staffing VPN in now and they're using that address at home, and if all your stuff is using something different, it helps them connect to different devices at the office. So,
Zach, do you see you have a question, another question in the chat from
okay.
me? What differentiates Wi-Fi from cellular office, etc.?
What was that again?
What differentiates Wi-Fi from cellular office and etc.?
Oh, it's the same thing. So, cellular office is actually a wired switch. With, it's about 16 port wired switch with the staff, and the staff Wi-Fi is on a different one, but the actual Wi-Fi, that's a separate switch. So they're both on separate switches because I'm running multiple access points for the Wi-Fi, and the VLANs they plug in. So the staff one plugs into port 1 on the VLAN switch, and then the access points plug into, I think it's port 4 on that VLAN switch. So that separates them out physically, all the devices. Like we're still using a lot of wired stuff at the office, and we'll cover why that in a second, but we do have a lot of wired devices when staff is in the building. We don't rely on Wi-Fi for our main office network. It's there if people need it, but it's not the primary. When they're separated out into these VLANs, then they need to go through the router or the router/firewall, and the firewall is what separates out that traffic. So like I was doing the Childifying example, the same applies for the Wi-Fi. If somebody's on the Wi-Fi, they can't talk to the staff network, and the staff network can't talk to the Wi-Fi. So that's kind of how that goes. And I'm actually going through the whole experience of us being isolated. I've come up with a few more security designs I'm going to implement when we come back on some of our Wi-Fi stuff. But right now, that's how things are set up. So I know I talked before, you don't broadcast your SSID. We don't, you don't want people driving by and, oh, okay, that's staff, I'll get on that. Like you guess one, you got to. People need to be able to get on easily. But once your staff is on, you don't really need to be broadcasting. So what I was talking about with the staff, like for Southeastern, most of the staff is already using wired because we have had for a number of years. So why not use it if you got it? But there's this whole, they call the evil twin. So if somebody, especially if you're in a densely more populated area, can be in the building right next door to you and set up an access point with your same encryption. If they know your encryption key and they know your SSID, they can then sit in the building next to you, and there's a good chance your laptop will join them, and now they're controlling all your traffic. They can see all your packets, and they can process them any way they want. So there's no real way to prevent that. There are some commercial tools to kind of look for evil twins and let you know they exist. I don't know anything that's cheaply available. They're usually part of a Wi-Fi intrusion prevention system, but those usually are, as much as I know right now, they're big money, like a couple thousand to do that. So I don't know on a small organization. If anyone knows anything on a wireless intrusion prevention system on a cheap side, please let me know. I haven't not come across one in a little while that I would say is affordable. But that's why we try it. So that's why you don't broadcast your SSID for your staff, because if you're not sending out information, you're trying to make it a little harder to get. Hopefully, somebody will have a hard time trying to set up an evil twin. But it does happen, especially if you're in a more dense area. It's definitely something to be aware of it happening. I've mentioned it once in a while. I don't know if the staff remembers, but once in a while, like it's at Southeastern, the clue would be if you join the Wi-Fi and you can't connect to the file server, well, then you know you're not on our network. So that's usually a key indication something bad is happening. But as another way to prevent some of this too is if your staff is using VPN, you don't even have to be off site. You can use VPN on site if you're on Wi-Fi. So then you don't even have to worry about the evil twin. If someone set up an evil twin and you join, but all your traffic is going over a VPN, there's not too much the evil twin's going to get out of that situation, because all your traffic would be encrypted because of the VPN. And even if they're even on the Wi-Fi on your actual access point, it's just good that it's another level of encryption that you're providing. The access points give you a little bit of encryption, which most people are always attacking, but VPNs provide another level of encryption to help make it harder for packets to get decoded. One of my first limitations of doing wireless at Maris was we had everybody put a VPN client. So you got on the wireless network and then you had a VPN in. And at the time that provided the authentication of only legit users and we're encrypting packets. At Southeastern, we have VPN access now. It's not required, but I know one or two staff members who do go on the wireless and VPN right back into the firewall. So it's a great security thing. I didn't even tell anyone to do that. I just know they do it. So if you're listening, you should be really happy with yourselves. But for VPNs, I think I'm at the end of what I was talking about. So I'll go over VPNs real quick.
Did you see sorry, it's Carolyn. Did you see the question in the chat about separating staff Wi-Fi from guest Wi-Fi?
Yeah, I'm gonna go look right now because I'm all on my slides anyway here. Let me see the chat. All right. Should you separate staff Wi-Fi from guest Wi-Fi? Yes. At Southeastern, we have two separate access points. We have a staff access point and a guest access point. So up until now, I did have Wi-Fi as one VLAN and one switch, but now I'm going to be switching that over. Nothing just because I have the room now. It was just stuff happened and it didn't get done right away. But yes, you should separate those out. They should have their own separate access point. How do this? For VPN, it's not too hard. I guess it's hard for me. I find it easy, but you can, in this case of a firewall, this firewall that we have at Southeastern has a VPN built right into it. It's open VPN. I recommend to people. So you can get the software for your clients. It's free to download at openvpn.net. Runs on every Windows, Linux, Macs, can all get in. And it's built, in this case, it's built as part of this firewall, which is in our case is a NetGate, which is using pfSense software. Oh wait, I'm not sharing, so nobody saw that. So share. So sorry. This is our VPN. It's built into the firewall, and all the staff have accounts. All the accounts get created through the firewall, and it works really, really well. It's definitely something I'd recommend. Up until this point, it was just meant for like one or two people who are off site to get in, and turned out it's a lifesaver right now for us, as the world has changed. Web-based VPNs, do they work well? To be honest, I don't have that much experience with that type of technology. I'm aware of them. I was working on a personal project with the local fire department and using a web-based SSL VPN, but then all this happened, so that project's got put to the wayside. So I can't really comment much more than that. I know people use them. I think they're okay. I always prefer the VPN clients myself. I think they're easier to work with. I guess for expense, let me go back to the expense side of the VPN question. So I said in this case, it was just, we paid the $600 for the firewall, so it was built in. You can, if you have the skill set up a separate machine on site, Linux or Windows, and you can get an open VPN server, download it, for free. That's, as I said, it's an open source project. There is a commercial side to that, but you can do it on site for free if you have that skill set. There's also some services that do VPN services. They're really meant for if you're if you're a commuter and you're kind of going all over the place. It's really meant to secure your VPN traffic if you're on Wi-Fi, because that's a whole other separate conversation on Wi-Fi in general. But like airports and hotels, bad places. Evil twins, a very populous place to get evil twin attacked. So if you're a frequent commuter, you can get a VPN service, and then you can at least encrypt your traffic on the wireless that you might be using at that time. But they're not really meant to, like, if you have a service at the office. So for like us, we have a file server at the office, so everybody needs to VPN in to get to that file server. And then I also encrypt our servers are up in the cloud and offline, not on site, but if staff VPN in, then they pick up the office IP address. Their traffic is encrypted to the servers, so it provides a lot more security in that way, especially if they're using home Wi-Fi now. I don't have to really worry too much about that because I'm forcing them to VPN in to do administrative functions. So VPNs are good things. I guess just show there, if you can buy this stuff, Amazon, you can buy it there. You can buy some things at Best Buy, has a commercial side of things. So they're not all that hard to get to. Prior to this, I did actually have a firewall that was doing all the VLAN switching and the firewall stuff and the routing stuff and the VPN stuff. It wasn't doing all that great of a job. I ran it for about 2 years before I moved on to my current step, which is working really well. I think it was probably maybe trying to do too much out of one little device. But all right, and with that, Carolyn, I will send it back to you.